Hi guys, in this episode of Shri series, we're going to be talking about kinetic energy and the formula and use an example to calculate kinetic energy here. All right. So if you looked at my previous video, we talked about potential energy and I clearly stated that potential energy is stored energy, energy that's stored before it's converted to other forms of energy. All right. Now, kinetic energy in a nutshell is energy that's in motion. All right. So when you think of the word kinetic, we think of the word motion. Something's moving. All right. So an object that is moving contains kinetic energy. A simple example, if you're holding a ball and you throw the ball from one point to another, that ball will contain kinetic energy. So energy in motion is referred to as kinetic energy. All right. So what's the formula for kinetic energy? The formula for kinetic energy is Ke. Kinetic energy is half mv squared. All right, where m is referred to as mass. So that's mass of the object in question, and mass is in kilograms. So the unit used to measure mass is kilograms, and v is your velocity. All right, now velocity is measured in meters per second. All right, now if you remember, and I know I haven't put this before, but I will put more videos, velocity is a vector quantity because it has both magnitude and direction. Okay, so kinetic energy's formula is half mv squared, so that's the formula we will be using. Okay, so if you look at the question says calculate the kinetic energy of a car of mass 2,500 kilograms traveling at 1,000 meters per second. All right. So when you look at this question, we need to find out what information do we have here. All right. So you can see we've got the mass and we've got the velocity. So what I like to do is, just like I showed in my previous video, we write down what information has been given to us. So we know m is 250 kilograms. All right, so that's a good thing. We don't need to convert any units, and we've got our v as 1,000 meters per second. All right, so what we now need to do is find the kinetic energy. So therefore we've got this formula here, and now we have to substitute kinetic energy is half, what's my mass, 250, and what's my velocity, 1,000 squared. Just remember, when it's 1,000 squared, it's not 1,000 times 2. All right, 1,000 squared is actually 1,000 times 1,000. All right, I've seen students make that mistake by saying 1,000 squared means 1,000 times 2. No, you're multiplying 1,000 again, or multiplying 1,000 twice. All right, so with that in mind, we get our calculator and work out what's our kinetic energy. So we get 1,000 squared times 250 and divided by 2. All right, so you're going to get a huge number here. So that's 1, 2, 5, and 6 zeros. 1, 2, 3, 4, 5, 6 joules. So the unit for kinetic energy is joules, just like potential energy or any other forms of energy. All right, so what we need to do is we get the 1,000, square it, multiply it by 250, and then divide it by 2, and you're going to get this huge number here. 125 million joules of energy is required, or of kinetic energy. So to summarize, kinetic energy is energy in motion. Anything that's moving will have with it kinetic energy. The formula for kinetic energy is half mv squared, where m is my mass in kilograms and v is my velocity in meters per second. All right, and then we looked at an example. We had a kinetic energy of a car of mass 250 kilograms traveling at 1,000 meters per second. Substitute 250 as m and 1,000 as v and square that, and you're going to get 125 million joules. All right, thanks for watching, guys. Bye now. In my next set of videos, we will talk about extra questions on kinetic energy. Thank you.